All right, everyone. Thank you for joining us once again on Did You Know, the ESCO HVAC show. So we have been on the road for 3 weeks straight. We've been down to the NAVAC Technical Training Facility. We have been down to the Fujitsu Technical Training Facility. We have been to the Hitachi Training Facility. And I just got back. Jason and I went down to the Department of Energy's Oak Ridge National Laboratories down in Oak Ridge, Tennessee, talking about technologies and transitions. And Ty, tell me some of the things that you've seen coming back from Fujitsu and Hitachi that encourage us to start bringing new technologies into the classroom.
Oh, it's just amazing how much everything's changed from, the days of contactors and simple capacitors to now we have multiple control boards in the system. When you first see that, it's overwhelming. When you first see all of these different parts and all the tubing, it looks like a piece of artwork, not something we could work with. And then after you take this class, you realize, oh, once you understand how it works, we can solve the problems. That's what we teach. We teach how things work so that students are empowered to solve problems. So, yeah, it's important to understand that this isn't technology that's coming. This is technology that's here. It's been here. It's being installed. These are what students are going to be working with in the field right now.
Exactly. And so today we're going to be spending a little bit of time with our friend John Martinsik. How are you doing, John?
Great. How are you?
Doing well. We
Hello?
originally were going to do
Good.
a conversation on, from the factory perspective, what does it look like for new technologies coming to the industry? And then we got a little bit deeper into the conversations that you like to have about actually preparing our students for what they're going to see out there. And so when Ty and I were spending time with our manufacturers, one of the things that we recognize is that our industry probably is not prepared for the speed at which we are advancing and developing, both technologically and in the classrooms as well. So let's talk a little bit about what you see for the advancements, especially on the machinery side, because you're in the machine manufacturing for schools and for manufacturers as well as contractors. So let's talk a little bit about what you have seen changing in this last decade.
There are tons of changes. Everything is getting much more precise, much more user friendly. And the other thing is, it's not just the technology that's changing. I'm gonna back up from just the technology, but the fact that the people, up until very recently, there's been a pretty large workforce. But now we're in a situation, most of the workforce ages 60 and can be retired within the next 5 years. And we could be in a world of hurt as a country. I was actually at, I believe it was Train down in Broken Arrow, Oklahoma. And they said that if they hired every student graduating from their public schools, each year the people that are retiring in the next 5 years. And so you have people that have all these skills because they've been doing it for 10, 20, 30, maybe 40 years. And now we need to bring kids in to that workforce ready to replace these people that are retiring because they can only stay on so long. And so the technology is making up for, in some cases, for the lack of skills that some of the kids coming out of school have, because it took, even thinking about someone starting out in a household, a lot of kids want to start out where their parents did after they've been there for 40 years. Most of them didn't have all their furniture and everything from day one. And the same thing is true of skills. And with the skills needed to do these, worked as an apprentice for quite a while. They worked and they saw many other old timers that they learned from, and they were able to gather those skills. So much of the new equipment that's coming out is also made to shorten that learning curve so that, for instance, in making a HVAC part on a plasma cutter, where someone that has been doing it for 40 years could get out of pair of shears easily with manual equipment, and it actually goes together, the tip student that hasn't had that life experience, it's not going to go together so well. So to have a piece of machinery that can do the precision cutting for them, so they just have to do the assembly, makes a difference. And that makes a huge difference for business owners, because almost everywhere I travel, and I'm working a lot of businesses, the thing they fear most is the ability to replace the people they currently have. So we have a lot of companies, especially larger corporations, that are flipping the bill to pay for us to have equipment. Not just schools aren't just dependent on the grant processes and Perkins funds and all the other funding sources that they've had in the past, but now major corporations and even small businesses are willing to help fund schools in their own communities because they're so desperate to get skilled labor to replace those that are retiring. And so this is one thing that shortens that curve of getting this new employee able to replace that old timer that is very skilled and has had, like I said, 10, 20, 30, 40
Yeah, absolutely. And that's really what we've been focusing on is we know that we have a very significant deficiency of talent in the industry. We're not bringing in new people fast enough. We're retiring faster than we are filling. So when we look at the innovations, that was one of the reasons we started with our tool manufacturer and we went to equipment manufacturers and then we went to go see what we're actually doing at a national level for, analyzing ways to become more efficient. So let's dive a little deeper into this presentation. And those that are joining us, we'd love to know where you're joining us from. Remember, this community is all about growing together, and we're very anxious to have you here and ask questions as we go along. Because remember, this is going to be about looking at ways to become more efficient as an industry. We have students coming into the field that are going to be required to be faster, more efficient, have better use of their time, and also have skill sets that are very different than they were just a few years ago. If we look at how things have changed technologically, like Ty and I seen when we went down looking at our equipment manufacturers, the time to diagnose equipment is becoming faster because we're using technology and we're using software, sometimes even with AI capabilities, to quickly identify what our problems are. If we look at from the production side of things, if we look like at installation, we were talking about doing sheet metal transitions as an example. There was a time where I had to calculate sheet metal transitions, sit in the shop and go, oh man, how many of these am I going to mess up before I get the correct one, right? Because I'm not going to send it out onto the job site for myself or for anybody else unless I know that the thing is actually perfect. Well, we're starting to utilize technology to make that so much faster and so much more precise. So we're going to try to bring this video in. And for those that are joining us, if you're not aware, there have been a variety of internet issues across the country today. So we're hoping things are going to be playing properly for you. If the video doesn't come through well, we'll just continue discussion. So we're actually going to use a video as part of a presentation instead of using slides today, but we're going to have some video to show along the way with that. So John, I'm going to try to bring this up and I'll put us across the bottom and we'll let you go ahead and try to hit the play and see if you can broadcast from your side.
Okay.
And Sue Wee, thank you for joining us from AGAS. Paul, glad to have you out here with us.
So I can't tell if it's a thing or not.
Okay. John Tyndall, thanks for joining us today. John, you're in the commercial HVAC side of things. You do any sheet metal design? Oh, there we go. All right. So, yeah, I'll be able to play. It's just going to be in a shorter box. We're actually playing off from YouTube, being able to have the actual band capacity on this. So, John, let's talk about the evolution of, particularly in the plasma cutting designs.
Yeah, plasma cutting, the technology has, if you want to kill the audio on that, it's coming through right now.
Oh, it is. Okay, fantastic.
So anyway, but go ahead and let it play and we'll start talking. But anyway, the technology has changed dramatically, even in the last 10 years. The size of the actual plasma units that would be like a huge table are, very small in comparison, much larger, almost to the point of being portable. And the cut quality is substantially better. It's really near laser quality, where at one time, the cut quality is like, okay, it's good, it's getting it done, but now that cut quality is so much better that it's that almost laser-like quality for a very small fraction of the price. Where you may have $150,000 with with a laser, you have a plasma cutter for say $30,000-$40,000 that's doing similar work and often actually at a faster speed. So that's gone
Okay.
well. The other thing that's changed significantly is, well, I'll give you an example. When we do training at a school, we normally require that the instructor gives us one male and one female student in addition to the instructors that are being trained. And a lot of times I would contact a school and they'd say, oh, well, we don't have any girls in our program. They will find one. And so they would get a girl from art or some other class, and maybe she was good in science. And often it was the only girl that had ever been in that shop area. And so we usually will notice that during that day, the girls keep coming in and checking on the girl in the shop that was never there before. And the next year, that instructor will usually have anywhere from half a dozen to 15 girls. Half the class is now girls instead of all guys. And the girls tend to really embrace the technology, and where getting their hands dirty on a piece of metal initially didn't sound very appealing to them, by being able to use the computer and make the parts, they're now really excited about it and really improving the program substantially, because the guys have to step up their game as well, because they don't want to be overdone by the girls. And the old, it's good competition that makes everything better. And so you have technology, like say, for instance, cutting these pipe parts that we're seeing on the video right now. The ones that are on the table are more a much better example of actually HVAC work and putting in pipes to transmit heat or fluid or consumables. It could be chemicals, it could be anything. And what we're doing on the demo there is just doing some lettering, which is actually far more difficult. The software automates the process so that you can have, say, in this case, we're using 6-inch tubing, and you tell it how you're going to meet together. Is it going to be a T? Is it going to be a Y? Is it going to be coming in at 30-degree angle, or is it going to be coming in at a 90-degree angle, like on the ones on the table there? And then maybe you have a 4-inch pipe coming into a 6-inch pipe. And so you give all the information, and it makes those seams perfect. That is something that would take a very, very experienced tradesman to do in the past. And now, with about a half a day of training, someone that's able to use the computer can make those same pieces. Now, I have some people that'll go, oh, they're going to replace us with this. They don't need as many people now. Usually it actually turns around to be needing more people, because as a business owner myself, if I can increase my production, I can sell more. If I can sell more, then that means I need to hire more people for the other labor, some increasing our cut quality and quality of our product at the same time. And then as we increase our quality and we increase our business, now everybody can actually make more money because the profit has now increased for the business. So these usually do not replace or reduce employees. Usually over time, it actually will add to employees. It also gives a small business owner, like a 1 or 2 man shop, the ability to build up that business to then be able to afford more people.
Yeah, we've been talking about how are we going to be able to fill the gap in our need for technicians and installers in our industry. And one thing that we can always agree on is that the HVAC and refrigeration industry is a very stable industry. We were required, to be working during COVID. When we look at some of the jobs that were losing the ability to work during pandemics, during a volatile market, we had a lot of people that were struggling to find new careers. And so we've seen a lot of IT professionals looking at what other things they could do, especially now as we're introducing artificial intelligence into the scenario. We have IT professionals, or we have students that are in IT programs going, am I going to have a job going forward? Well, if we start looking at ways that you can implement the technology into the HVAC and refrigeration industry in applications like this, well, now we're actually increasing the amount of technicians we can supply to the industry if we broaden the scope of what HVAC and refrigeration is. A lot of our programs will be side to side in a school, in a vocational program. We'll have CNC programs. We will have electrical programs. We'll have HVAC refrigeration programs. We'll have IT programs, not realizing that many of those actually have the ability to be cross-productive when it comes to job placement going forward, because the technology is now moving into things that weren't heavily automated just a few years ago. We don't think about machinery being automated in the HVAC industry, but we should, because now we can move some of our talent more into the field and bring in new talent to be able to work with the technology that we're introducing.
Absolutely. What you're seeing now are some different models of machinery. Because we work with schools, not every machine can be a $200,000 machine. A company may be easily able to fit a $50,000 to $200,000 machine, but a school, not necessarily. So our fully assembled, we set people up for success from day one, because when we go in and do that initial installation, we train them, get them started, and often, as long as they have their power and electricity and everything ready, they're running the first day. And often we'll leave having made at least 10 parts in that first day, where a lot of people will buy machinery that's the cheapest. It's a kit that takes 40 to 80 hours to build and may never actually run. And we also have a 3-year on-site parts and labor warranty, which is totally unheard of in industry. Normally in machinery, you're lucky if you have a 1 or 2 warranty, but if you have a problem, usually you're going to spend anywhere from $3,000 to $7,000 per visit to get somebody on site to work on it. So we provide that kind of support to ensure that our customers have that type of success. And so we have best in class at every price range. So we have machines ranging from a little over $10,000 on up, and we also have used machines. We take machines in on trade and we rebuild them, and often are able to keep people that are on a really tight budget. They get started. We have lots of times we'll have small businesses that don't have a lot of funding, and we'll get them started on a used machine. In a matter of months, they trade it in on a brand new one because they've made enough money with that used machine to pay for the faster, bigger machine. And so that's kind of a great way of success. We do that with schools as well. Right now, you're seeing that we were on Mythbusters Junior. Adam had our machines used in making things to bust myths, as well as making the props for the studio. The studio that I got to spend a little bit of time in, the studio is really cool. It's actually the same studio that most of the Star Wars episodes were shot in. So it was really a cool place to be in. And they did, one time when I was there, the kids that they were working with were all dressed up kind of like astronauts and so forth. Right now what's coming onto the screen, I'll go ahead and comment on it. In addition to actual HVAC parts, which we're going to get into, you can do the artsy kind of things that are fun. And, we have, even like farmers that will get a machine and then they're making different art pieces that they're selling, during their slow periods. And, it helps add additional streams of revenue by being able to do other things. So, you may be slow with work this month, so you do some other things that you either sell online or within your community. Schools, will often use this type of thing. Right now, I'm in Winslow High School in Arizona. I'm not standing on a corner, but in the school. And they've had a machine here for about 12 years. So they've been using it for about 12 years, and it totally changed their program, because instead of selling fruit or Slim Jims or whatever to raise money for their programs, they're actually making products that they're selling and are able to fund themselves in addition to their other funding agencies that they get. But student competitions and a lot of the fun things often aren't covered by the tax dollars or through Perkins funding and some of the other federal dollars. So they need to find other ways to raise those funds. And you're in a smaller town like this, they don't have a lot of money without being creative. So this equipment, in addition to being able to be used creatively commercially, it has totally changed many schools. We have schools with some of our equipment that have made high schools making over 100,000 a year. We have some colleges making more than $500,000 a year with products that they're actually producing, and maybe even supplying local business with what they need, and teaching students real world skills. I often have teachers who can't compete with local industry, but when you have a school that is really preparing students with real world skills and they know what they're doing when they get out, they're sought after. So I have a school in the middle of nowhere, Kansas, and they have companies employing their students not only from Kansas, but Oklahoma, Texas, Missouri, Nebraska, and Colorado. I mean, so they graduate like maybe 30 kids a year, and they're sending their kids all over because they actually know what they're doing. And the companies in their town in that small area, which should be really worried about, if anyone was worried about it, would be in these smaller communities where there are less jobs. They're tickled pink that a school is supplying with students that can graduate and they can put right on the job and they know what they're doing. Never, as if for the schools that are in on this call, make sure that you're not afraid to compete. Talk to those businesses and let them know how you're going to make a better worker. And these companies will probably be glad to sub work to you so that their students know what they're doing when they graduate.
You know, that is such an interesting conversation. When we think about ways to implement our classroom, we tend to struggle with funds. I mean, Ty, that's part of being in a classroom, is understanding where you're going to be able to get the components that you need to be able to teach the things that your curriculum is designed for. If we start thinking outside of the box and go, okay, well, what if I work with our CNC department? We got one that's here, but maybe they don't have the right equipment. What if we can work together to be able to bring in pieces of equipment, work with our local advisory board for components that they need, and actually start teaching how to supply these components right out of the classroom, and now turn something that would have been an investment now into a revenue generating opportunity for your program. It's such a novel idea. I just went to Missouri here a few months ago, and I visited a school it was an agricultural school, but all of their students manufactured something that was sold in the college. So they actually built goods and sold goods to be able to pay for their classroom. And because of that, tuition was actually free for their students, for in-state students. So I think about utilizing technology in an HVAC department to start manufacturing things that can be sold as goods. I know myself, when I was doing residential installation and design, even things like a transition that would have taken hours to manually design and create, if that could be done in a classroom in a very short period of time, it really kind of changes things. Great question, Perla. So does it calculate transitions? We are actually right there. That's a very good segue.
Yes.
So we're actually going to take a look at digital transitions that just blew my mind when I started thinking about how much time.
Yeah, go ahead and turn the volume on the video.
Okay. Let me hop over here real quick.
Just going to go to the top here, reducing for...
All right, is that playing through?
Yes.
Yep.
Okay.
The connector at the bottom would be the...
Things that would take a lot of time before, now it's a matter of just kind of plug and play and letting the software do the calculations and conversions.
So every 1 1/4, 1 1/2, flange out.
So explain to us what we're doing right here, John.
And then the top would be a...
So what's happening is this elbow is being designed, and the person that's actually doing the training here is interacting with the instructor for this part that they've made hundreds of over the years. So it's a part that they have to make within their curriculum. And so he's asking them, how do you make it? Because everybody has their own way of doing things. And the beauty of this software is that it can learn from the way you design, and you can tell it, I want this type of seam. I want to go from 6 inches to 4 inches, or whatever it is that you're going to do. And you can type all of those in parametrically, and you end up with perfect transitions that when the machine cuts it out, it goes together perfectly and works the first time.
Okay.
Interesting.
Material, what? 26? and then the same sheet size.
So this is an
96
instructor working with a student to
If that
actually
all works
input
okay,
the
everybody's happy
data.
with that, we would go to
Yes.
save. It'll generate your 2D images here and your 3D images here. Then we would go to nest settings, tell it we want to nest all of them, just the one. We would change the sheet size back.
And we're actually going to do
What you used
an
last.
actual cutting of this
If
in
that's
this
all
video
okay
here in just a
there,
second, so you can see what
go to
it
nest.
transcribes to once we go into the actual machine.
And you have your one sheet. It's only using about 14 inches by the 48 long.
And so the software is
So
trying to
we actually just trim off
maximize
that excess,
the
and
surface
we'll let you
space
do
that's
that
on the
there.
sheets.
Right. So you also have better use of your materials because of the nesting.
Yeah,
Make sure your
exactly.
path
Nested
is
based
correct,
manufacturing.
which is correct, and your gas is correct. And then here, same thing, just reports, nest summary. Your summary and your labels you have to do after you've posted it. If you do it before you've posted it, you won't get any information as far as the sizing, the material, or the image there.
And so you can actually use these for creating your material list for Classroom.
Yes.
That,
And you can even actually print out labels to put on each piece to know which side goes up and how they go together.
Mhm. Yeah, the directional topography.
want to call this reducer.
Anyone have any questions in the chat? There's still quite a few people out here hanging in with us. I know it's a little difficult not being able to play this in full screen, but unfortunately the internet bandwidth has slowed down a little bit, not allow us to run this in full screen mode.
Then you have your
Some of the questions that I see coming up will be actually answered because the whole process of putting this together is going to come up on the screen.
Excellent.
As we go through. There's actually about 15 minutes of assembly time on this.
We have that directly
Okay.
there. We just click on that and then just add labels.
Wonder if I can tell you what. While this is running,
Process.
oh, it's getting ready to print. Okay, never mind.
Yep.
The CAD software, and the stall lines are cutting movements, dash lines are rapid movements. Then it actually shears the piece off at the end. And so now we're going to.
Wish the audio was a little bit better, but you'll get the idea once you see it working.
Right, absolutely. See if I can bring it up a little better here.
It's set up to automatically
There we go.
sense the height of the material. And then begin cutting.
So if I had an entire sheet of these designed, I could slam out multiple pieces in one
Right.
cut through.
In fact, in the software, you can actually lay out a whole commercial building and then have all of the pieces nested and ready to run.
Really? So you can pre-program everything, do that as part of your exercise, and then when it comes to actual class day of cutting, then we can do it all as one project.
To be the correct
Yes.
voltage to maintain the correct height in making these parts.
It's actually really fast. I remember the days of actually doing this with hand shears and Sharpies.
My dad still does it that way.
Does he really?
He
He's
has
gonna
all
watch
the math in his head and he lays it out and maximizes the metal and does all his calculations and cuts it by hand. So when I'm seeing this, I'm thinking, well, this is cool. This would be a lot more fun.
Absolutely. So, John, one of the questions that did come in when we're looking at, say, a machine like this, what kind of footprint are we looking at for placing it in a classroom? Because a lot of times we are limited with our floor space.
Right. And we have different sizes. I believe this one was a 5x10. So basically, the foot, it usually takes about 2 feet more than what the travel is. So a 5x10 would be like 12x7. 4x8 is kind of like 10x6. 4x4 is about 6x6. And then they actually go down to 4x2, but it gets a little less practical for making real parts once you get that small. Usually you need at least a 4x4 to be good.
Excellent. Okay. All right. Do we want to go through the rest of that, or the rest of it's just assembly once we get to that point, isn't it?
Yes.
Okay. So I tell you what, we're going to take a real quick break. We're going to bring a short video from one of our sponsors, and I will see you all in just a few minutes. What we're going to do is we're going to show you a classroom that Ty and I just went down and seen from one of our manufacturers, and we're going to try to start promoting different training facilities as we start moving into into the approach of the National HVACR Education Conference. Throughout the year, the ESCO Group team evaluates the training classrooms from many of our vocational programs across the country. But we also have the wonderful opportunity to explore training programs brought to you by our equipment manufacturers. This opportunity, we were able to visit the Johnson Controls Hitachi training facility in Irving, Texas, headquarters of a cutting-edge training facility and an immersive product showroom. This 10,400 square foot facility is designed to serve as a comprehensive customer experience center. It offers in-person HVAC training courses tailored for contractors, technicians, installers, and it provides a blend of theoretical knowledge and practical skills. The center aims to elevate the proficiency of HVAC professionals, ensuring that they are equipped to handle the latest advancements in the industry. We are very grateful you've taken the opportunity to check out this impressive training facility. We encourage you to learn more at HitachiAirCon.com or email the contact at be.training@jci-hitachi.com. Thanks for joining us. Well, I think internet's going to get the best of us today, John. I've been trying to get this to go back and play, and it is just struggling. I know some of our internal people were having issues with remote internet today, so I may not be able to bring that one back in. I think we actually just lost John. So I think he's having some internet issues as well. So that's really what we want to dive into is, preparing a generation for not just the technologies, but understanding the innovations that are happening due to technologies. Ty and I have had that ability to get out and explore classrooms to see the transitions that are happening and, help prepare an industry for what we need in the classroom. So Ty, while we're waiting for John to get back, anything you want to dive into on transitions of education for our students and for our technicians?
Well, I can tell you, I think this might be the most expensive show that we've ever done because my wife now wants a plasma cutter for
I
Christmas.
seen that. Well, he does have some good used ones that we might have to get with him and see what kind of deal he can cut on. Because I think I'd be
Oh,
interested in that.
you're cutting out there. You're cutting out. I can't hear you.
Cutting out. No partners on the plasma cutter, I hear.
Oh, it's just amazing that's what's out there. And our generation has grown up with digital. They've grown up with computers and phones and all this technology, whereas we had to learn it. I'm sure you and me had to learn it the hard way, using the long math and cutting things out by hand. And it's not not all that inviting. And if we think about we have the technologies out there and we have the generation that's just grown up natural with that, I mean, it's a really great combination that can really benefit businesses and moving our industry forward. Instead of having to have stuff shipped out from overseas, we can still make it right here with the technology, with the equipment, with the people that want to do the work. So being able to use how we see things visually, entering in those numbers, having it do that cutting, and then you still have to have the hands-on. You still have to work the metal. But I remember my dad trying to grow his business was always a problem finding somebody else that could do all of that layout work. That was a huge bottleneck. And seeing now we have the technology to where even smaller shops can implement this and grow and move forward. If we would have had this a long time ago, I mean, who knows where I'd be today?
Yep, exactly. And that's really what the goal of this episode is about is, to show that our industry has changed. And as educators and as contractors, we have a responsibility to be aware of the things that have changed in a very short period of time so that we can provide the resources for our industry. We are very aware that we're not going to be supplying enough technicians for our industry to meet the demands of an escalating technological revolution. I mean, we always talk about we're in this technological evolution. We're going to see technologies changing. We have refrigerants that are changing. We have a lot of legislation that is happening at a federal level that could even change education in a short period of time, looking at potential new training for our mildly flammable and highly flammable refrigerants going forward. So it's going to be up to us to look for the resources to better enable our industry. I see John hopping back in here. Hey, there he is. Now we got some signal coming through. Yeah, John, I won't be able to play the rest of that video. It's just, even though I got enough bandwidth, for some reason, YouTube is not wanting to transfer properly today. I know you had a video. I don't know if you were wanting to play any more, or if we're just wanting to wrap the conversation up.
I think we can. What I'd like to do is offer the link for that YouTube video to those that are on the call, and they can watch it later if they would like to see the complete production of that part afterwards. I did that because I am in a smaller town where I knew my internet wasn't going to be the very best, and I was afraid I might lose you. So it was kind of a backup plan just in case we had a problem with it.
Yep, absolutely. All right. Well, I think we're going to go ahead and wrap her up.
Any other questions? Most of the questions have been really good.
Yeah, absolutely. There's been a few that have came through. Like I said, the footprint was the last one. Is Ty going to buy his wife a plasma cutter for Christmas? That's another one that came through. Well, you missed that one just now. Ty's wife wants him to buy a plasma cutter now for Christmas. So we'll have to continue that conversation later. So we are hoping to see John at the National HVACR Education Conference coming up in March again at Las Vegas. We're going to have a lot of new education that is coming from our manufacturers talking about all of these transitions, better ways to equip the classroom, better ways to equip the industry, and getting comfortable with the changes that are happening all around us. All right. Well, I think we're going to go ahead and wrap it up for the day. John, I really appreciate you hanging out with us today. Maybe sometime in the future I can get over to the facility and we can do some recording and show an actual training.
Yes, we'd love to have you in our factory. We have a 67,000 square foot factory in Pennsylvania with all types of equipment set up, ready to run and make almost anything.
Excellent. And so I'll put the link up there again for those that are looking for more information. You can get a hold of John's website at www.forestscientific.com. Any other contact information you'd like to share while we're here today?
Sure. I'm probably the only CEO in the world dumb enough to do it, but I freely even share my cell phone. So if someone has specific questions, you can reach me. And that cell phone is 412-726-0574, 412-726-0574.
All right, fantastic. All right, and so we're going to hop out of here today. Everyone try to stay cool. I know it's hot all over the country. It's kind of burning up here in the Midwest. And we will see you again next week on Did You Know, the ESCO HVAC show, as we dive into A2L certified, A2L compatible. What do those mean, Ty? I don't know that they mean the same thing. Do you?
They're a little different, yeah, and I think it's something we need to talk about, and we need to talk about the importance of getting trained and educated for that, and the importance of having that certification, even though it may not be required yet, which is still in the works, or not, we don't know yet, but to have that to say, show your customer, and to say, hey, I'm certified. I didn't just, go and read about it or hear about it or learn on my own. Like this is a change in our industry, and I'm prepared for that change. And I think that's important. And we look at all the other trades, there's always changing and things happening. The automotive side, there's a certification for all different kinds of things. And I think that we should be embracing that and learning as much as we can and being prepared. And we know that there's a lot of different variety of people out there. So, hey, let's get certified. Let's show that we are professionals in what we do, and adapt to these changes, because one thing that's constant is change.
Change. Sounds like a great conversation to me. All right, everyone, have a wonderful week, and we will see you next week on Did You Know? The ESCO HVAC Show. Bye, everybody.
Bye.